Hello everyone. In this lecture, we are going to look at front-end frameworks and the role they play in web app development, where Angular is a classic example of a front-end framework. So let's start off by looking at what a web application is. A web application is simply any software application that runs on a web server, and you access this application through a browser over the internet or within a company intranet. So classic examples are social media apps like Twitter, X, Instagram, Facebook, okay? Cloud file sharing and backup like Dropbox or Google Drive, web-based email like Gmail, Outlook, e-commerce like Lazada and Shopee. The key features of a web application, they run inside any kind of web browser. So Chrome, Firefox, they utilize a client-server architecture. So the app itself runs on a server somewhere in the cloud, which accepts user input from the browser, which is the client, and then the server processes this input and then generates a customized response that's written to it through the internet or intranet. And web applications are designed to be platform independent, so you can access them across multiple devices as long as a browser is available on that device. So let's take a look at a classic example of a three-tier web application, which is typical for the vast majority of web applications deployed in use today. So right at the top, you have what is called the presentation layer, or more popularly known as the front end or the client side. Okay, and this pretty much runs in the browser. And then you have the business layer or the back end or the server side, okay, which runs on a server in the cloud. And then somewhere close to the backend server, you have another separate server that runs a database, which we call the database layer or data access layer. So let's talk about the client side, or we also call it the front end or presentation layer. And this is essentially what the user interacts with in the browser. So the client side or the front end app essentially renders the UI, okay, what you see, and it also provides a smooth user experience, UX, so the user can interact smoothly with the app. It captures user inputs such as entry in the forms, clicks on specific buttons, and even gestures. And it communicates with the backend server or the server side or the backend using HTTP requests, typically through an API that's exposed by the backend app. Okay, so this is your front end or client side presentation layer. And as we can see, the three most common languages you are going to use to implement this will be HTML, JavaScript, and CSS. Okay, so this is a classic example of a front end of a banking application, Maybank. Another example of a front end of an e-commerce app, Lazada. Now, the server side, or what we also call the back end or application layer, is essentially the essence of your web application. It's the brain of your web application that executes the core business logic of whatever the web app is designed to do. So, for example, if you are an e-commerce application, then basically that will be doing things like processing sales transactions. If you're a banking app like Maybank to you, be processing banking transactions. If you are, for example, Instagram, X, Twitter, then it would be updating social media posts, okay, in response to requests sent from the client side. And it will also generate dynamic content in response to these requests, and then it will return it to the front end. And most importantly, of course, in today's world, you need to have security. So all the security aspects, such as authentication, authorization, validating the data that's been transferred from the front end, encryption of the connection, is all done by the server-side app. Okay, so this is your server-side or business layer, or the back end. Okay, the server-side business layer or back end. Okay, and you can see there are a variety of languages and frameworks that we can use to implement this, which we'll talk about in a bit more detail in the later portion of this lecture. Finally, we have the database layer, and this is basically where you store any data related to your application. So the fundamental purpose is to persist data, that means you want to make sure the data is still retrievable after the app has shut down. And the data must be very relevant to your business logic. So example might be users, information about the users, about products, orders, social media posts, and so on. Okay, it should be able to perform CRUD. Okay, this is considered the basic functionality of any database: create, okay, record, update, sorry, create, read, this should be read, create, read, update, and delete, okay, all the records inside the database table. And optionally, most databases can also do some form of analytics on the data. And it should be able to support a large number of CRUD transactions in a scalable and reliable manner. So if we talk about banking apps and e-commerce apps, you're going to have a large number of transactions happening within a very, very short period of time, and the database must be able to support these transactions without corrupting data and without losing any of the data involved in the transaction. Okay, so this is your database or data access layer. Okay, and you can see the names of several popular databases here, which we'll talk a bit more later on in this lecture. So when we talk about development work, typically we can roughly segregate development work into two areas: front-end development, okay, and so Angular is essentially a front-end framework, and so this workshop is going to be focusing on front-end development, and also backend development, which simultaneously looks at the server side or backend application development, and also the databases that the backend app will interact with. Okay, so let's dive into front-end development, which is basically what this workshop is about. Angular is all about front-end development. So the front-end core languages are HTML, which is essentially to structure and also to provide the content for your web page or for your web app. CSS to provide the styling and the layout. JavaScript, which is to provide the dynamic interactivity, so you can see stuff happening on your UI, on your web page of your web app in real time. And TypeScript is a superset of JavaScript. Okay, it's an evolution in the development of JavaScript, which includes the feature of static typing. Okay, now JavaScript, when it was initially conceived, was a dynamically typed language, which means it doesn't have the idea of types, which is essentially how you classify your different kinds of variables. So JavaScript or traditional JavaScript didn't have the concept of like integer data type or string data type, and then you cannot assign different values to different data type variables. It didn't have this concept that you might have in, for example, C++ or in Java. So JavaScript does not have, or the original version of JavaScript, the initial version of JavaScript didn't have static typing. It was a dynamically typed language. But because of a variety of problems with dynamic typing, later versions of JavaScript, which TypeScript is the classic example, now utilizes static typing. And most modern front-end frameworks, including Angular, use TypeScript. So let's look at the popular frameworks and libraries for front-end. So for CSS, probably the most famous framework is Bootstrap. And there are also other popular ones right now, such as Tailwind and Material UI from Google. And in terms of JavaScript frameworks, we have React, probably the most popular front-end JavaScript framework. And then, of course, Angular, which is what we are studying today in today's workshop, Vue.js, jQuery, and Svelte. So here we can see a collection of a variety of CSS frameworks, and you can see beyond the ones that I just mentioned, there are actually quite a large number of options out there, but most of the time people tend to stick to a few well-known ones. So Bootstrap would of course be the classic one. So then there's of course Tailwind, Bulma, and Material UI, and so on. Okay, and then of course, front-end JavaScript frameworks, the two most popular ones, or should I say the three most popular ones that dominate the market, are React, Vue, and Angular. Okay, let's just briefly compare between the different front-end frameworks and libraries. Now, Angular is what we call a full framework, which is once you use Angular, you pretty much don't have to import or utilize other libraries as dependencies in your Angular app, because it has pretty much within Angular itself is pretty much everything you need for a full front end framework. Okay, and I'm going to run through in detail what are the so-called fundamental features of a front-end framework. But essentially, Angular has it all, which means you don't need to import any additional libraries, or most of the time. I wouldn't say all the time, but most of the time, you will not need to import any additional libraries to make your Angular app work properly. Okay. The only problem with Angular is because it is such a complete framework, it incorporates every single functionality possible. The learning curve is very high. It takes a long time to learn and understand it. And it is, for that specific reason, it's typically only used for large enterprise apps. So we're talking about apps that are really huge. They have lots of people interacting with it, large client base. The UI is complex, and it is running mission critical workloads. Okay, so classic example with banking apps, financial apps, financial gateway apps, e-commerce apps, and so on. Okay, React, probably the first JavaScript library you're going to hear of if you ever talk about front-end development. Now, React is not a full framework. It's only a UI library. So really, it's just handling the UI aspect of the front-end framework. And because it is very basic, the learning curve is medium. And you can quickly get started on it without too much difficulty. And so most modern web apps use React for that purpose. The drawback of React is that because it is only by itself a UI library, you will typically have to import in other JavaScript libraries as dependencies in your app to do other important stuff like state management, security, and so on. Okay, so that's React. So Angular and React pretty much dominate the front-end framework today in terms of JavaScript front-end frameworks. Then you also have Vue, which is quite popular. It's a progressive framework which combines so-called the best features of Angular and React. Okay, uh, and it's open source. It's developed within the open source community, unlike React, which is associated with Meta, and Angular, which is associated with Google. Vue is pretty much open source. Learning curve is low to medium, so not too hard to learn. In fact, probably a bit even faster than React. Okay, so it's really very attractive for startups and mid-sized apps. Okay, and you have Svelte, which is kind of a niche framework. It is what's called a compile time framework, very fast to learn, and it is very useful for high performance apps where performance is the critical factor for your app. So that's a brief summary of probably the most widely used front-end frameworks. And for today's workshop, we'll be looking at Angular. Now, what are the key features of a front-end framework? Okay, just now I said that Angular is a full framework. So Angular pretty much has every one of these features as compared to these three other frameworks, which typically will have to import other libraries in order to accomplish all these features. Okay, so let's take a look at all these features one by one. Firstly, a front-end framework usually has what is called a component-based architecture, which means instead of rendering the UI as a single HTML, single CSS, and single JavaScript file, it will break the UI into modular building blocks, or what we call components. So each of these smaller blocks or components, they all have smaller pieces of HTML, CSS, and JavaScript. And then you compose your overall UI by putting together all these smaller blocks. And this is what we call a component-based architecture. The second aspect of a front-end framework is it does data binding or reactive state management, which essentially means that when the data in your application is updated, so the value of your variables, the value of your arrays, the value of any lists that you have, or your data structure, which essentially is your application state, when that is updated, okay, any part of that data structure content, which is actually shown in a UI, will also be updated automatically. So you essentially want to synchronize changes between the variables, lists, data structures in your app and what is displayed in the UI. Okay. Then you have routing. Routing essentially implements what is called single page application functionality. And I'll talk a bit more about this when we come to that particular feature in our workshop. So most modern front-end frameworks are SPAs in that once you load the initial HTML, okay, that becomes the single page of your app. You will no longer continue to load HTML from your backend server. So it's a single load at the initial load up time of the app, a single HTML, okay, with the CSS and also the JavaScript app, in this case, say Angular. And then after that, as you navigate through the app, essentially your app will just make HTTP calls to the backend server to retrieve additional data or CSS or HTML content, and then it will reference it. So the backend will no longer return a full HTML file anymore, other than the first initial load. Okay, and so that's why it's called a single page app. Okay, so therefore, this is a very important aspect of routing in most modern front-end frameworks. Next is HTTP and API communication. So the back end needs to communicate with the front end, and typically this is done through API endpoints that are exposed by the back end. And there are several architectural ways or approaches for the front end to communicate with the back end. The most popular one is called REST. Okay, pretty much you would say 70 to 80% of industry uses REST API endpoints exposed by the back end, which are interacted with by HTTP requests that are sent from the front end. So the front end needs to be able to do HTTP API communication. State management. Okay, you need to be able to manage the data in your application. So your application, your front-end app, is not just going to be one single JavaScript file or one single TypeScript file. It's probably going to be composed of 10 to 15, 20, maybe even 50 different TypeScript files. So all these TypeScript files, they are going to contain data structures such as variables, lists, arrays, and so on. You need to be able to manage all this data in all your data structures. Okay, so you want to be able to keep track of, for example, use case, which is the user that's currently logged in. So as you navigate through different pages using a SPA experience, you want to be sure that you are keeping track of who is the current logged in user. You want to be able to make sure you keep track of what are the latest items that have been placed in the shopping cart and so on. Okay, you don't want this data to be lost even as the user navigates between different pages in your web app. Okay, so all of this constitutes state management. Form handling is about making sure that user input, which is typically through some kind of form control, is handled properly. So for example, you need to have validation rules to validate that the form entry by the user is valid. So for example, when I mean valid, it's a valid date, it's a valid email address, a valid phone number, a valid physical address, and so on. All these rules have been encoded in the web app. Then you need to have some form of error handling. So if the user enters an invalid input, how do you handle this error? How do you notify the user? And how do you submit a completed form to the backend through a HTTP request? Then building and bundling your front end app. So while you're developing your code, everything is kind of optimized for development, and the code is just as it is. When there's not much transpilation done, you just work with the code as it is, as we'll see later in the workshop, right? But when the code is ready to run on a production server, okay, you're going to deploy your front-end web app onto some web server for other people to download. And at that point, you have to transform your development code into optimized form for deployment and usage by your clients. So this involves a variety of what we call build tasks. You have to transpile. Okay, transpilation is a special form of compilation which is to convert TypeScript to JavaScript. Because browsers don't understand TypeScript, browsers only understand JavaScript. So although you develop in TypeScript in Angular, you will have to transpile that to JavaScript. Then you have to put all that JavaScript code into a suitable single bundle to make it easier to download across the internet. You have to minify the bundle, which is you need to compress the code into a much simpler form so that the bundle is downloaded is much smaller than than what you would normally have in the normal JavaScript code. And then you would need to process any CSS files and minify it appropriately, and also optimize images that come along with the bundle along with the app. Okay. Then you have dependency management, which is to allow the framework to access additional external libraries to augment the functionality. So as I mentioned earlier, I said Angular is pretty much a full front-end framework. So typically you won't need to have any additional external libraries. However, sometimes if you want to make your Angular app more pretty, there are UI component libraries such as Angular Material and Material UI. And these are basically UI libraries that are also used as part of Google's products. So you can also import those libraries if you want, right? State management libraries typically are not used for Angular because Angular has pretty good state management. But if you are working with React, for example, you would probably need to have state management libraries. And if you want to do very niche stuff, like you want to do charting, data visualization, you want to do very cool graphs and all that, then there are separate JavaScript libraries for this. And all of these have to be integrated into your front end app. So the framework must be able to do this dependency management to allow your app to access these libraries correctly. CLI tooling, okay, command line interface tooling. So pretty much all front-end frameworks have this, which is essentially to improve developer productivity and to provide consistent architecture. So from the command line, so from PowerShell or from a command prompt, it allows you to generate a project structure. We call this project scaffolding. So it generates the entire project structure for you, the appropriate folders, the appropriate skeleton code for the various files that are needed for a full app, whether it is React or Vue.js or Angular. All the skeleton code is generated as part of the project scaffolding. Okay, so you have this all ready for you. The structure is consistent, so everybody's app will have the same project structure. Okay, and you also have a live development server, which means that while you are working on developing the app, every time you make a change, the live development server will immediately pick up the change, so you don't have to constantly stop the server, then compile your code, then start the server again, then stop the server, compile the code, start the server. You don't have to do all of that. The live development server automatically picks up the changes that you make, and then it automatically restarts the app. So you see your changes happening in real time very quickly. So all of this is to facilitate developer productivity. Then performance optimization is to make sure that your apps are fast and scalable. So remember, the apps are basically going to be downloaded across the internet to a browser on a device. Most probably this is going to be some form of a mobile device, because 90% of the world accesses apps through their mobile devices. So the apps have to be fast, okay? They have to render very quickly. They have to be scalable. And so we use a variety of techniques. So lazy loading, for example, you load modules only when you need them rather than loading every single module for app at the initial load time. Server-side rendering means that instead of waiting until the app reaches the mobile phone or the browser of whatever device is loaded to, and then actually rendering the HTML and CSS, you will render it on the server side first, process it, and then you just load the rendered version to your mobile device or to whatever device you are using, you're having your browser on. So these are kind of, you say, optimization features, and very important in today's web app environment, where pretty much everybody accesses, like I said, web apps through a mobile device. And lastly, security support, which is just essentially to protect against common web browser attacks. So cross-site scripting, cross-site resource request forgery, code injection attacks, and so on. These are all very common kind of attacks. And so all front-end frameworks typically will have to provide some form of security to protect against them. And they also need to provide support for HTTPS, which is nowadays pretty much mandatory. Every time you connect to some website, your browser will mandate that a HTTPS connection must be forged or must be created. So a front-end framework pretty much must provide support for this. All right. We just briefly take a look at back-end development just to make this lecture complete. So for back-end development, you can pretty much use any library you want. Yes, sorry, you can pretty much use any major language you want, unlike front end, which pretty much is only JavaScript. Okay, so for back end, you have a variety of languages and also libraries in those languages. So JavaScript obviously is still a very popular option for back end. So the most popular one is actually Node.js, which is the runtime environment for JavaScript outside of the browser. Before Node.js, you can only execute JavaScript inside the browser. With Node.js, you can now execute JavaScript on your desktop without the use of a browser. Okay, and the frameworks that are very popular within Node.js is Express.js. So this is probably the most popular backend framework if you are using Node.js, but there are also a variety of other alternatives such as this. Then if you're working with Python, which is very common in a machine learning and AI environment, then the most popular backend libraries for your case would be Django, Flask, and Fast API. If you are working with Java, which is very common in the banking industry, in enterprise application development, and where reliability and consistency is very important, where Java is very popular, then Spring Boot is pretty much the go-to choice for your backend library. If you're working with C Sharp, okay, then it's essentially going to be ASP.NET. That's Microsoft's core development library or framework for backend development. If you are working with PHP, which is very popular for WordPress sites, then there are a variety of very popular backend frameworks for that. Backend frameworks in PHP such as Laravel, Symfony, and Cake PHP. Okay, so here we can see a list of some of the top 10 backend frameworks. Okay, ASP.NET, Flask, Spring Boot, Express, and even Phoenix. Now, for the API, which is a very critical aspect of the communication between the front end and back end, you have a variety of architectural styles available. So the older styles, you probably won't see this anymore, but just for information, there's this thing called RPC and SOAP. These were probably used about 15 to 20 years ago in order for front-end apps to communicate with the back end. You are rarely going to see any one of these styles anymore. Pretty much the industry has more or less settled on REST API for communicating between the front end and back end. And in certain cases where there is still a niche demand for high speed, complex communication, which is not so well done with REST, okay, GraphQL has become the popular choice. And it's a growing community that's working on GraphQL. So this is probably something what you see in cutting edge apps. Okay, they will use GraphQL to implement the API infrastructure for communication. And there are a variety of authentication methods for REST APIs. So if you're using the REST architecture for implementing API, these are some of the authentication methods, and these all will have to be implemented by the backend app. And finally, the databases. So for databases, relational or SQL databases are still the mainstay option of choice. They have been very popular workhorses for the past 20 to 30 years. They're still very popular today. So some of the more well-known ones, MySQL, PostgreSQL, Microsoft SQL Server, Oracle DB. These are still very widely used in the industry. They are reliable, they are proven to work, and so on. In the past 10 to 15 years, we've also seen the emergence of what we call NoSQL databases, which don't follow the relational schema structure of so-called relational databases. So these databases, they have different structures in which they organize their data, and they're pretty much intended for environments where there's large amount of data and you need to replicate your data, and you need to not be able to you're not able to consistently how to say, you're not able to consistently centralize your data reads and writes into a consistent scheme or view across multiple locations. So when your data is distributed, data read and writes are also not being very consistent, okay, which is typical in big data environments. Then you are going to use NoSQL databases. The most popular one is MongoDB. All right, so let's take a look. You can see this is really pretty much the most popular databases in 2025. You can see the top four are still the traditional SQL or relational databases. And then below that, you can see the most popular NoSQL database back then and still today is MongoDB. Now, beyond the back end and front end development focus, which is the core aspect of full stack development, you also need to look at what we call DevOps, which is how do you deploy your application and how do you get your application out to your customer as quickly and as efficiently as possible. So with respect to this, you have containerization platforms, which allow you to put your app, and this can be either your backend app or your front end app, into a container, which is an isolated environment, to allow you to deploy this app through a systematic manner, regardless of which platform you're deploying it on. So whether you're deploying it on your development machine, on your QA QC machine, or your production server, you interact with the container which you put your app in a uniform manner. So containerization is pretty much a de facto standard now for deploying apps using a DevOps methodology. And the two most popular ones are Docker and Podman. Orchestration is a follow-on from containerization. It's basically about how to manage a large cluster of containers, and Kubernetes is also pretty much the de facto standard for that. And then you have your CI/CD pipeline, or your continuous integration, continuous delivery pipeline, which essentially enables you to deliver code from the development machine to the production server as quickly as possible. Okay, so GitHub would be where, for example, you store your code. This is a code repository. And then tools like GitLab CI, Jenkins, Circle CI, all these are CI/CD pipeline tools that allow you to pull your code, do testing on it, build the code, put it in the container, deploy it onto a appropriate deployment server. And of course, nowadays, most companies tend to deploy some or most of their apps onto a cloud platforms. And so different cloud platforms have different features or architectural tools for you to deploy to deploy your apps, whether they're front end or back end. Okay, so the three main cloud platforms today: AWS, GCP, and Azure. Okay, so full stack development covers the full range of all these developments. So you got the front end, you got the back end, working with the databases, DevOps, which I briefly talked about just now, and also mobile app development. Okay, so if you are a full stack developer, you kind of have to know everything, and it's kind of moving towards this direction now in the industry, that a lot of companies are expecting their developers to be full stack developers. So you kind of need to know front end, back end. You need to know how to deploy your stuff to the cloud. You need to know how to work with your CI/CD tools, DevOps. Okay, you need to know how to work with databases, and you also need to know how to develop on a mobile app. So either using the specific language for that particular device, so whether it's an Android phone or Swift for iOS, or a cross-platform library that allows you to develop for two different environments or phones at the same time. The term tech stack is used to actually refer to the set of specific languages, libraries, and tools and platforms that you use to build an application. So this means all the specific languages and libraries for front end, for back end, for database, DevOps, and your infrastructure, and any tools you use to support your development, that essentially constitutes what is called the tech stack. And every single company that has a significant investment in software development, they all have their own tech stack, their own unique tech stack, right? So outside of the unique tech stacks that different companies have, we also have popular stacks, kind of generic popular stacks that are kind of very widely used. So for modern apps, you have what is called the MERN or the MEAN stack. And for basic websites that was used like maybe 15 to 20 years ago, you have the LAMP stack. Pretty much nobody does this anymore. Okay, but for modern apps, these are the two stacks that are very widely used: MERN and MEAN. So MERN and MEAN, they both tend to involve what is called full stack JavaScript. Full stack JavaScript means you use JavaScript for the front end and also for the back end. So for the front end, of course, you will have to use JavaScript. That's only JavaScript for the front end. So Angular or React or Vue. And for the back end, you use Node, okay, together with Express.js or Meteor or one of these other frameworks. Okay, and then of course for database, you have a variety of either relational databases or NoSQL databases. So the mean stack is basically MongoDB. So ignore the Mango here. It's actually MongoDB. So it's MongoDB, and then that's your database. Then at the back end, you have Express.js running on top of Node.js, and then at the front end, you have Angular. So that's mean, okay, MEAN. And then you have MERN, which is just a slight difference from that. It's still Express and Node at the back end, MongoDB as your database, but the front end you use React. So MERN and MEAN, pretty much the only difference is what are you using for the front end. And as I mentioned earlier, the two most popular frameworks for front end is either Angular or React. And if you go to a particular site called StackShare, you can actually check out what are the different tech stacks for the different top tech companies that you have across the world. So this is very informational for you. It's also good for you as your development as a software developer, just to see what's out there and what's popular in the industry right now. Okay, so that brings me to the end of this presentation on front end development.